right, so we're going to date this August 20th. And then we're going to call this Chapter 2 review. All right. Now, it is Chapter 2 review. We're going to review out some of the major concepts. Actually, looking at those pre-tests, you guys did a pretty good job. All right. But again, clearly it indicated some things that you have not been taught, all right, before. So I'm going to review some of the things that you did well, and then I'm definitely going to hit some things that obviously you have not seen before. All right. Chapter 2 mainly deals with solving equations, all different types of equations. Okay. So let's put solving equations under there, because that's important too. Okay, so but there's a lot in it, and then they expect you to be able to apply and all that kind of stuff. All right, now before we start solving our equations, I want to make sure you've got some vocab down. All right, I'm pretty sure I gave you most of this vocab back in December, but if I had, let's go with just an expression. I know I just said it's solving equations, but let's talk about our expressions. All right, an expression is what? It does not have a equal sign. Okay, it doesn't have one of those. So I might have something like 8x to the 4th plus 3x squared plus 10. Okay, that could be an expression. Okay, now as it sits right there, does anybody remember what form that's in? There's a name for it. It's in what's called standard form. Okay, we talked about standard form. I may have even had you put things in standard form back in December. All right, but standard form just means what? We take a look at those exponents and we make sure that they're in decreasing order. All right, this plain constant 10 really has an imaginary 10 to, or x to the 0 power sitting there. Why? Because anything raised to the 0 power is always 1, and 1 times 10 is just 10. All right, so clearly those are in decreasing order of the exponents. So that means that that expression is in standard form, okay? And then I believe, hopefully, you know things like this. Like if I give you something like a 3x squared in compared to maybe say a 2x plus a 5, compared to maybe a 4x squared plus 3x minus 10. All right, now there's 3 different expressions, right? They have names. Do we know what they're called? What's this one called? The one in the middle. Let's start with that one. It's got 2 terms, so think of your prefixes. Anybody remember? Maybe not. Do we know what the first one's called? Do we know what the last one's called? Does anybody know what these are called? Vocabulary type things? No? Okay. All right. This is one term, right? It's one term. So it's a monomial. Okay. Now, have you heard that word? Yeah. Aha. Yep. So it's just been a while since you've done it then. All right. So 2 terms is not a polynomial. Binomial. Okay. 3 terms is a trinomial. You guys may be saying the right answers, okay, but like I can't hear. The mask is like killing us here. I can't hear a darn thing. All right, anytime over 3, then that's when we refer to it as a polynomial. All right, any number of over 4 terms, okay? So let's do this. 4 or more terms is generally referred to as a polynomial. Okay, so just some vocab that I wanted to make sure that you had. Here, let's do something else since I'm on this. Let's do an example like this. Let's suppose I had a negative 8x squared plus a 3x minus 6. Okay, so that's a trinomial, right? Is it in standard form? Yes, it's in standard form. Okay, now if it's in standard form, this first term is called the leading term. Okay, that might be a brand new vocabulary word. Okay, that first term, if it's in standard form, then that's the leading term. Okay, in that leading term, then I can determine two things about that trinomial. I can tell that the coefficient is what? Coefficient is the, not the -6, but -6 is something else and it starts with a C, so you're getting close. The coefficient of this leading term is the -8. All right, so the coefficient is, I don't want to put an equal sign, so let's do colon, is -8. It's the number in front. All right. Now, there is something called the degree of the polynomial. All right, and as long as it's just got a single variable in there, you look at the leading term, and then you look at the exponent, and you can tell what the degree is. So the degree of this is 2. All right, so the degree is determined by the exponent in the leading term. The coefficient of the leading term is -8. All right. We talked about that -6. It is a term, right? Because we said this is 3 terms. It's a trinomial. But this one right here, what is special about this? It has a name and it starts with a C. It's constant. Okay, so just going quick over some vocabulary to make sure you understand that, because I'm obviously going to be using those words, all right, this whole year, all right, and so the vocabulary as I talk, all right, it's really important. I write down things, yes, but I don't always write down everything. So just because it's not written down doesn't mean you're not responsible for it. You've got to listen to what I'm saying, and when I use vocabulary words, then you've got to key into those that they're important, okay? All right, so definitely I think that there's going to be questions on there that you need to do that. Okay, so now let's actually start in with some equations. All right, so we're going to be basically, I know you're pretty good at solving equations, all right, and you just might need some extra practice because it's been a while. There's all different types of equations, okay? So there's one-step equations, and I'm not going to do one of every type, but I'll just kind of spell them out here. There are two-step equations. There are multi-step equations. And then there's the kind that's got x on both sides. All right, so in an Algebra 1 class, that's about where we're at, okay? We start you, and you started this early in middle school, right? You did one step, you did two-step, and then last year you were up to the multi-step and x on both sides. All right, but just to refresh, all right, your memory here. One step could be an add one, a subtract one, a multiply, or a divide, okay? Now I'm going to do the hardest one of all of them, okay? How about if I did a 2/3 x equals, no, I don't know, let's say 10. Okay, 2/3 x equals 10. That's a one-step equation. All right, I want you to work it as a one-step equation. All right, the 2/3 squished up against that x means to do multiply, right? So right there, we're seeing multiplication, but the opposite of multiply is divide. So I need to divide by 2/3, right? But that's kind of nasty. I don't want you to write, I do not want you to write divide by 2/3. Okay, because this is arithmetic, not algebra. I don't want you to say divide by 2/3. I want you to understand what dividing by a fraction means. Dividing by a fraction means, how do you divide fractions? Yes, fraction bar. Yeah, say that again. Yeah, keep it, switch it, flip it. So if I divide by 2/3, that's the same thing as multiplying by 3/2. All right, that's what I want you to do on this. Multiply by 3/2. It's a whole lot easier. Multiply by 3/2. All right, it's a quick, very quick way to do this. All right, so on the left-hand side, 3/2 times 2/3, that's 1. It all goes away, which is what we wanted to happen on that side of the equation anyway. All right, now hopefully you can multiply this really quick in your head. You'd multiply 3 times 10, which would be 30. 30 over 2, 15. Okay, x equals 15. All right, but that's a one step that you probably didn't do a lot of last year. You might have done like 2x or x plus 3, okay, but one step equations means you have one step to get the answer. Okay, let's do on a 2-step, let's do like a 2x plus a 4 equals a negative 10. Didn't leave myself enough room here. All right, so you did tons of those. You have been doing those since 7th grade. Okay, so first step, you always have to do what? You have to add or subtract first, multiply, divide second. So we're going to what? We're going to minus 4 minus 4. We're remembering this, right? Yep. Okay. All right, and then we're going to go 2x equals what, negative 14. And then you're going to show the division with that horizontal bar, divide by 2, divide by 2. Okay, so x equals negative 7. Okay, so those are 2-step, but I just wanted to do one real quick just to make sure that we do this. Now, multi-step can be like lots and lots of things. They can have distributive property. They can have some combining like terms, but for the multi-step, at least in the beginning in an Algebra 1 class, x is always on the left-hand side because they've got the next category after that, they start moving x to both sides. So I might have something like a 2 parentheses, negative 3x plus, I'm going to try to make this one kind of ugly, minus 5x. No, that's not as ugly as I wanted it to be. Let's not make that a 5 because I want this to try to turn out to be not so much. Let's make this make it a 9. I think that'll make our answer a little bit worse. Equals, let's put an 11 over there. Okay, because I want you to encounter a certain thing. I'm hoping this is going to work out this way. All right, so if this is a multi-step equation, what's the first thing I have to do? Distributive property. Okay, so I'm going to take that 2 and I'm going to distribute the 2. So that's going to give me negative 6x plus a 14 minus a 9 equals 11. Okay, then what am I going to do? Combine like terms. So I got a negative 6x. I got a minus 9. So what's that going to be? A minus 15? Don't let me make a mistake. Plus 14 equals 11. All right, now at this point, this ought to look like a what? This looks like a 2-step equation. Okay, so once you get to there, it's the same stuff that you've already done. We're going to subtract 14 from both sides. Negative 15x equals, what is that, like negative 3? Okay, now, did I do that right? Yeah, I did. Okay, now, would I divide both sides by negative 15? So if I divide by negative 15 and I divide by negative 15, the negative 15's cross out. Negative divided by negative is positive. Does 3 divided by 15 come out even as an integer? It doesn't, right? But, so I don't want you to go to a decimal because yes, you could turn it into a decimal. It's not a bad decimal. All right, but if I just ignore all this, doesn't that look like a fraction? Because it is. So can I take 3/15 and reduce it to lowest terms and get a 1/5? Yeah, so leave it. Don't rush and go to decimals all the time because, yeah, granted, 1/5 is like 0.2. Okay, so it would have been a nice decimal. But what if that would have turned out to be some, you know, like 1/7? If that would have turned out to be a 1/7, 1/7 is not a nice decimal. It's a great big long decimal. It repeats, I think, out 6 or 7 digits. Okay, so then everybody in the room would have, somebody might have rounded to the nearest tenths, somebody else might have rounded to the nearest hundredths, and then we've got that whole argument of, well, my answer is equivalent. Leave it like that, and then everyone in the room has that exact answer. Okay. All right, did you do X on both sides last year? Yes. Okay, good. All right, so again, I'm going to try to make this not turn out so nice. I could put distributive property in it. I could put some combining like terms in it. So I could do a negative 3, 2x minus 5 plus 6x equals negative 2x plus 8 minus 9x. Yes, I'm just randomly making this up to see how horrible I can get. And I can make these as long as we need to. You do one thing at a time. Okay, one thing at a time. If you see distributive property, that's always first. Okay, I've got distributive property on the left. On the right, there's some adding like terms. You can do more than one thing in a step. On the right, I could go ahead and put those two together. All right, but on this side, the only thing I'm going to do is distribute. I'm not going to do anything with that 6x right there. So negative 6x, distribute again. It's going to give me a plus 15 plus 6x. This is not what I wanted to happen. Equals, we're going to change the problem here in a minute, so I hope you're not too far ahead of me. Plus 8 minus 9x. I did not put them together on the right-hand side. All right, right here, let's change this to a 16 because I don't want that term to fall out. Okay. All right, now let's go ahead and put some like terms together since I didn't add the like terms on the right-hand side. Negative 6 and 16. What's that going to be? 10? 10x plus 15 on the left. Negative 2 and a negative 9. Negative 11x plus an 8. All right, I even did this with you in December, didn't I? Yeah, I did. So we did this. We added 11x and then we added 11x. And then we crossed those out. And then didn't I let you in the same step do minus 15 and then minus 15? Yeah, all in the same step. Just makes it faster that way. Let's see, this is going to be 21x. And then this is going to be negative 7. All right, and then see this one, when we divide by 21. All right, reduce it to lowest terms. 7 goes in 7 once, 7 goes in 21 3 times. So x equals a negative 1/3. And again, see, 1/3 is that repeating decimal. So do we write 0.3 with a line over it, or does somebody decide to round to the nearest tenth, or somebody else decides to round to the nearest hundredth? Leave it like that, and then we know we all have the exact answer. By the way, this is the only exact answer. I mean, 0.3 with a line over it would be an exact answer too, but this is the nicest one. This is the way I want you to do it. Okay. All right. Now, I'm assuming that that's probably about as far as you've got because of the questions that were missed in the pretest. Okay. Up to this point, you work these out. You are always getting an answer. Okay. And we're always going to get some type of answer, but we don't always have to have a numerical answer. Okay, so there's going to be some special cases for solving equations. All right, so let's do special cases for solving equations. All right, let's suppose we have a 4 parentheses 3x minus 15 is equal to a 12 parentheses x minus 15. All right, your directions are going to say solve, okay? And you're not going to know that this is any different than any of the ones that you've already done, like, because we've been working out tons. All right, so you're going to start to work this out just like you always do. All right, you see some distributive property on both sides, so you're going to distribute that 4. You're going to distribute the 12. Okay, so 3 times 4 there is going to give me a 12x. 15 times 4, that's 60, minus 60. And then distributing that 12, 12x. 12 times 15, 180. All right, and a minus. All right, normally I don't do that big of numbers. Okay, now this is a x on both sides, right? Okay, so I take this 12x and it's positive, so I'd subtract 12x, right? So if I minus 12x here, then I would minus 12x over here. 12x minus 12x is 0, right? So it crosses out, which is what we want to happen. But over here, it also crosses out. Okay, it also crosses out. That can happen. It just did. It can happen. All right, I have a negative 60 on this side left over. I have a negative 180 on that side. Common sense, does negative 60 equal negative 180? Not last time we checked. That's a false statement, all right? Negative 60 does not equal negative 180. This is a false statement. Okay, now the false statement is not the answer. That's not what you write on your paper. All right, stop and think about what this means. I'm trying to find a value for x. It means it's a no solution. Did you do no solutions last year? You did them with me? Yeah, but I only had you for 2 weeks. Yeah, okay. We did a lot in those 2 weeks. Okay, I forgot we did a no solution. All right, so it's a no solution. So then we know that's going to happen. Now, usually in your textbook, they don't make it very challenging because you're going to do a bunch of them. They group them together. All the ones in this section will have answers, and then they go to another section, and then all of those are no solutions and identities. Okay. However, when you take a test for me, it's going to be all mixed up. So you might work one problem and get an answer. The next one might be a no solution. The next two might have answers. The next one might be an identity. Okay. So that's going to be, they're going to be all mixed up. All right. So let's do an example then of an identity. Okay. So let's see. This one I hope is an identity. Negative 3 and then 6x plus 4. And then equals a negative 18x and a minus 12. Okay, so again, if you're not thinking ahead or you're not kind of looking at what you got going on, you may not catch it right away because you're just going to dive in and start working the problem like you always do. So you see that distributive property over here, and then you're going to distribute it. So that'd be a negative 18x and then a minus 12. All right, now if you're paying attention to what you are writing on the paper, at this point, you should notice the left-hand side equals the right-hand side. Okay, so that tells me what? What am I going to put in for x that would make this true? Anything, right? Whatever if I put, because whatever x is, if I put 3 on this side and I put 3 on this side, I get the same thing. I get a true statement. All right, now, for those of you that don't pay attention when you work out your math problems, you might not catch it at this point. Okay, you might not catch it. And that's okay. Can I keep going and keep going and keep going and still figure out that it's an identity? Yep. All right, so if I was going to keep going, I would add 18x. I would add 18x. And again, my x's fall out, but this time I got a true statement. Now, true statement is not the answer. You don't write down true statement. You write down identity. Okay. Now, do I have to keep doing this and go all the way down to get that true statement? No. If you recognize that it's an identity right here, you're fine. Cash, you look like you had a question. Did you have a question? Yeah, you look like it. Oh, I saw a finger. Okay, I thought I saw a finger go up, kind of like you're gonna, yeah. Okay. All right. Okay, so those are in this chapter 2. The identities, the no solutions, that sort of thing. All right, let me look at the other questions. Okay. How are we doing on time? It's 2 o'clock. We got plenty of time. All right. Let's look at just some different types. All right, you might see equations that look like this: x minus 3 over 4 equals 10. I'll throw that up here. Let's throw another one in. Let's do maybe an x minus 4 over a 4 equals a 3/4. Okay, so different. What you'll see different this year than you did last year is you'll maybe see more fractions. All right, so that doesn't mean you don't have to freak out or anything. I'm hoping that we can do both of these. All right, this over here, what's the first thing that has to be done? The divide by 4, right? Okay, don't try to get rid of the 3. The main thing that is taking place on this is that division. So you've got to get rid of that 4. Okay, so that's your first step. So instead of dividing by 4, I'm going to multiply by 4. That has to be the first step because that division is the main concept. So this breaks our rule of always add or subtract first and then multiply or divide. This is an exception to the rule. Okay, so x minus 3, 4 times 10 is 40. Add 3 to both sides, 43. Okay, but I did want to throw that in there because if you always think, oh, I got to add or subtract and then multiply or divide, it's not always the case. That would be an exception to that rule. All right, now this, I have basically a fraction on the left. I have a fraction on the right. When I set two fractions equal to each other, it's called a proportion. It's called a proportion. Okay, and it doesn't matter that I've got letters in it, or I could even have some distributive property. It doesn't matter what the numerator and denominators are. If I have two fractions that equal to each other, it's called a proportion. All right, easiest way to solve a proportion, I don't know if you were taught this or not, but cross multiply down. Okay, some people call it cross products. All right, cross multiply down, all right, will work. Now I'm going to actually show all the steps. When I multiply this way, I've just got 4 times 3. Okay, so we can do that in our head. That's 12. Okay, then I'm going to put the equal sign down. Now, when I distribute this, or when I multiply this way, I'm not going to distribute. I'm going to show that multiplication. I'm going to show 4 times x minus 4. Don't try to distribute that in your head. Okay, show it. 12 equals, now that you've got it written down so that you can see it, now distribute 4x minus 16. Now it's a two-step equation, right? So add 16, add 16. Is that 28? 28 divided by 4? 7? Okay, so if you see proportions, cross multiply down, it's the easy way to do it. You see little strange ones like that, and you want to make sure you multiply both sides first. Okay. So far, so good? Okay. Going once, going twice. All right. Now, this idea of this proportion, again, I don't know if this was shown to you before or not. There's about 3, 4, 5 different ways you can do problems like this. Let's do something like, what percent of 96, doesn't look like a 6, 96 is 72. All right, you did tons of questions like this in middle school. All right, let's throw another one on here, just something that's phrased a little bit different. What is 21% of 85? All right, you remember doing these? Okay, now you may not do it the way I generally teach it, but here I'm going to show you. All right. Yes, you can look at all the different types of sentences and just go, oh, well, on this one I divide, and on this one I multiply, and on this one I do this, and on this one I move the decimal, and then I multiply. All right, or you can work them all out the exact same way. Okay. I can write, no matter what the sentence is, no matter how I phrase that sentence, if I use is over of equals percent over 100 as a proportion, and I fill that in, then I can work out all of them the exact same way. All right, so did I show you this? No. Okay. All right. Now, what I like to do is I like to go through and I like to find the percent first. All right, this question says what percent? So does it give me a percent? No, so this problem doesn't have a percent because it's asking for the percent. So that's my x. Whatever I'm asking for is my x. Okay, now logically, that 96 has got to be paired with the of, because if I didn't, then the 72 would just be dangling out on the end. So the 72's got to be paired with the is. Okay, now the is number goes on the top left, the of number goes on the bottom left. Percent goes here, 100 always goes here. So my proportion is 72 over 96 is equal to, I don't know what percent it is, over 100. Now I've got an equation that I can solve. Okay, cross multiply down. So cross multiplying this way would give me 96x. 72 times 100 is going to be 7,200. And I'm going to whisk out and grab a calculator real quick because I don't want to do that in my head. So divide by 96, divide by 96, 75. Now, so I got 75 when I did that on a calculator. Is 75 my answer? Got to put a percent. Got to put a percent sign. I don't need to move the decimal, do anything at all. When you use this proportion, you don't have to mess with the decimals at all. So final answer, all I gotta do is add the percent sign because it asks for a percent. Okay, all I gotta do is add that percent sign to it. Okay, now on this one, I always look for a percent first. Is there a percent in this problem? All right, if there is a percent given in the problem, all right, the percent is the percent, so I can't box in the word is with it because it can't be two things. And I can't box in the word of with it because, again, it can't be two things. It's the percent, okay? The 85 has to be boxed in with the of, all right? And then what is, the is number is what they're asking you to find, okay? So once you take your sentence and you box in everything you have, then you can follow your proportion. All right, top left-hand corner is, so we're going to put the x there. The x will move around. Okay, the x is going to be based on what you're looking for. Of is 85. The percent goes on top. It's 21%. The way this is set up, all I got to do is write the number 21. Don't try to move any decimals. Don't do anything funky to it. Just take the number and write it down. And then put your 100 in there. If you can write that proportion, then you're good to go because then you're going to cross multiply down. Again, I do not want to take 85 times 21 in my head. All right, so cross multiplying this way, I get 1785. Cross multiplying this way, I get 100x. Divide by 100. What's dividing by 100 do? Yeah, it moves the decimal two places. So 17.85 equals x. All right, now, do I add a percent to this answer? No, because it didn't ask for a percent, it just wants a number. So I don't have to add a percent sign to that one. Okay, so if no one's ever showed you that way, that works. It's really nice, kind of convenient. Okay. Now I want to do some geometry with the algebra. All right, there were questions that were on the pretest that incorporated what you should know or know about geometry and then applying the algebra to it. Okay, so let's call this geometry applied to algebra. All right, now, hopefully from middle school, you have a basis of a little bit of geometry, okay? Let's do a couple of these. If I draw a picture of two lines crossing, and let's say I put a 2x minus 4 over here, and I put a, I don't know, a 6x plus 2 over here. What can you tell me about this angle and this angle? They're equal. Yes, yes they are. They are equal. Do we know the name of them? When two angles are across from each other and equal to each other, they are called vertical angles. All right, so I was hoping that you had that from middle school. Okay, so that's just a geometry fact. Now, obviously, it's going to say find the value of x. Okay, so find x. So what am I going to do? If I've got to figure out what x is, I know these two things are equal. When two things are equal, Yeah, set them equal to each other and write yourself an equation. All right, because you know their vertical angles and vertical angles are equal to each other, I ought to be able to say 6x plus 2 equals 2x minus 4. Now I've wrote an equation. I ought to be able to solve the equation and then come up with an answer. So minus 2x minus 2x. We did this all in the same step. So we subtracted 2 and subtracted 2. All right, so what's that going to give me? It's going to give me 4x equals 4, 5, 6. Wait a minute, want to add negative 6? Don't let me screw up. Divide by 4, divide by 4. All right, now, how are you going to write your answer? X equals negative 3 halves. Just leave it 3 halves. No reason to turn it into a mixed number. No reason to turn it into a decimal. Leave it like that. There's nothing wrong with that. So that's one geometry thing. I don't think you saw that in the pretest. All right, I think you saw something like this. I think they gave you, and I'm just going to draw. I never draw a scale. Okay, here's a nice little triangle. If I mark two sides equal, what type of triangle? Isosceles triangle. All right, if I mark those two sides being equal, what else can you tell me about the triangle as far as things being equal? Ooh, gotcha. You got isosceles. Okay. All right, if these two sides are equal, then the angles that are opposite of them, so this is a side and its opposite angle is here, and here's a side and its opposite angle is here. If these two sides are equal, these two angles are also equal. All right, and little lines in there makes them equal to each other. It's markings in geometry that show they're equal. All right, now if I tell you that, I don't have enough room there, so let's say that that one is 3x plus 9. All right, and like on this first one, I just wrote the algebraic expression in there, okay? But that obviously is going to do what? It's going to give you the degree to that angle. I think in Math Excel, they're really, like, they do good notation like that. All right, and then, of course, I never draw the scale, but let's just say that one is 45 degrees. All right, no one says I have to put an X in both of them. I can put anything I want there. All right, now again, same concept. If things are equal, what can we do to them? Set them equal to each other, okay? So 3x plus 9 equals 45. And then I ought to be able to, if I'm trying to find x, let's write that down because I didn't write that down. All right, if I'm trying to find x, minus 9 from both sides. What's 45 minus 9? 36, so I'm going to have a 3x equals a 36. Divide by 3. Then I get a 12. So x equals 12. If it says find x, it's 12. Now, is there a way I could check this one? There is, isn't there? How could I check this? Plug it in. If I take x equals 12, I should be able to plug it back in here. 3 times 12 is 36 plus another 9, 45, and it better be 45 because if these two are equal and this is 45, this better be 45. So I can plug it back in. So I can plug it back in the picture, think of it there. I could also plug it back in here and see if it makes the equation true. All right, so they did do this, they're going to do that. Like the Algebra 1 book that you're going through now is going to expect you to apply some concepts to previously learned concepts. So this is solving equations, but they're giving you the problem in the context of geometry, okay? And that's okay, you just have to apply. All right, now, I don't think there were questions that were mean, median, mode, range. It asks you to find the mean, it asks you to find the median, it asks you to find the mode. Those are measures of central tendencies. Yes, they're in chapter 2. All right, however, I'm not going to review that. Some of you missed it, all right, just because you couldn't remember what median was or you couldn't remember what range was or mode, okay? So we will save that, all right? I'm not going to put that on the chapter 2 test, okay? We're going to leave that and do it because I think when we do that, we'll mess with some statistics and we'll use our graphing calculator and do a little bit with that as opposed to just what you did in middle school with that. Yes? Yeah. This is, yeah, fair game. Yep. So, say what? You will have to solve it. Like what I'm going to do is like give you the picture and then I'm going to say find X. Okay. So pretty much what the problems are looking like in Math Excel. All right. Friday's homework assignment, which is tomorrow, is going to be out of your book, out of the book. So questions that show up on that, all right, will be fair game. Today's Thursday. So on Tuesday of this week, what did I do? I gave you all those properties of real numbers. Okay, so you ought to be able to, I ought to be able to give you an expression, and then you tell me it's the community property of addition. Okay, anything that we have done in class, anything that's been in Math Excel is going to be fair game. I also gave you the classification chart, classification of numbers. That was on Tuesday. All right, and then I said, okay, so you've got some number, like, let's see if you've got it memorized. I don't know. If I gave you the number 1/2, give me every name that 1/2 could be called. Rational and real. Is Jordan looking at his little chart? Are you looking at the chart? Oh, no, I thought you were looking down. I thought you had the chart out. Oh, yeah, but I wanted to see if you had it memorized. So you gave me the answer, right? Oh, who gave me the answer? Oh, so sorry. With the mask on, I can't tell when your mouths are moving, when their mouths are not moving. I can't tell where the sound's coming from. Half the time I can't even hear you when you talk. Can you hear me?
Yeah.
Yeah, what'd you say? I'm good. Okay, I wanted to make sure I'm talking loud enough with this mask on. Okay, so yeah, 1/2 is a fraction. All right, it's called the inside part of that chart. It's rational, and then you work your way out. It's rational and it's real. Okay, if I gave you -3, what's -3? -3 is a integer. So, yep, you got to work your way out the chart. Okay, so I'm going to expect that chart memorized because you're going to have to give me classifications of numbers. All right, so pretty much anything that we talked about, any of the days that I've lectured, all right, it will be no calculator. It says that on the calendar, okay? We will take no calculator tests and quizzes. We'll take calculator tests and quizzes, and then we'll take some where you can, it's regular math, but you can use the calculator. All right, but we will also take specific calculator quizzes. That way I know whether or not you're actually learning what you're supposed to be learning, okay? No, it'll be reasonable numbers that I would expect you to be able to real quickly work out. Yeah, like kind of like similar to what I've been, number size that I've been doing in class, okay?
So the other thing I get confused on in the classifying numbers is, so if it's a repeating decimal, it's not rational.
That is rational.
And then if it's just ongoing,
Forever and ever and ever,
yeah,
that's irrational.
Okay.
There's really only 2 types of irrational. Pi, because that goes on randomly forever, and then square roots that you cannot do in your head. Like I can do square root of 4, right? That's 2. All right, but I can't do square root of 3 in my head. All right, I could on my calculator. It's going to give me a decimal. It's going to give me 1.7 something, 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 and it's going to keep going forever and ever and ever. So square roots you cannot do in your head, and pi is irrational. So really, that's kind of easy. That's only like 2 main things there. Okay. I could have a fraction that goes on randomly forever and ever and ever. I can't do one off the top of my head, but there are those.
And then irrational numbers, they are real numbers, right?
They are real, yes, because real is broken up into 2 main categories, rational and irrational. Yep. All right, so did we have any other questions? Okay, we've had some pretty good discussion. All right, so what I would do tomorrow, obviously you have a written assignment, okay, for chapter 1, chapter 2 concepts. So obviously clearly do that. All right, and then either on Friday or on Saturday or on Sunday, all right, sometime prior to you taking the test. All right, if you're a little confused, go back and watch some of the videos. I have almost, at this point, almost every Zoom lecture on my website under there. All right, eventually I will stop recording them because if you're at home and you're logged in, you're seeing it. So I will eventually stop that, but right here at the beginning, I'm gonna keep doing that. So you could rewatch them. You could redo problems. The way you study, I don't want anybody to say, oh, you can't study for a math test. Okay, you can study for a math test. You can memorize vocabulary and you can work out practice problems. All right, you work out practice problems. You could retake your notes and do a problem that we've already done in your notes, cover up the answer, and then see if you could work it on your own. Okay, but that's how you work problems to study for a math test. Okay. All right, so does anybody at home have questions? Like everybody in here in the room. Guys, you guys need to be quiet in here so I can hear them because I don't know how good their sound's going to be. All right, you're not opening your mic, so I'm assuming you guys are good. You got to unmute your mic and ask me a question if you've got one. All right. I'm not getting anything from anybody. Okay, so see you guys later. I'm going to end the meeting.